Hello, children. Today I will be absent due to medical reasons. We'll start working with chapter 15 that involves scale, drawings, bearings, and trigonometry. Okay. The first lesson we're going to see is about scale. Okay. Here we have page 336, scale. We should have seen scale in second year when working with ratio. Okay. The idea is a scale. It helps you to convert information that is in a map into a real life, okay, or the other way around. If you have information or values in the real life, you can convert it to do a map, okay. So how is the ratio given? The scale is given as a ratio, for example, like this, 1 to 50,000, or like this is a ratio. And let's do an example. For example, let's say that you have a ratio. For example, ratio, sometimes they give you the ratio in this form, under this form. Is, for example, 1 centimeter, 50 kilometers, okay? This is a ratio. This means that 1 centimeter in the map represents 50 kilometers in real life. So let's say, for example, that you have a distance in the map that you measure and it's 3 centimeters, okay? How do you know the distance in real life? The distance in real life is 50 kilometers divided 1 centimeters. Why the kilometers in the numerator? Because the real distance is measured in kilometers. And when you multiply this value by 3 centimeters, that is the distance in the map, what you do is you can simplify centimeters and you are left just with kilometers. And now the real distance is 150 kilometers. Let's think the other way around. Let's see, for example, that you have a distance. You have the distance in, I know, 200, no, 300, 270, okay, 300 kilometers, okay? This is the information, and you want to find the distance in the map. Since the distance in the map is going to be measured in centimeters, you know that the relation is 1 centimeter equals 50 kilometers. When you multiply this by 300 kilometers, again, you can simplify the units, kilometers and kilometers, because one is in the numerator and the other one is in the denominator. And then the distance in the map will be measured in centimeters. That is okay. Okay, the distances in the map are measured in centimeters. And the distance here will be 6 centimeters. So given the distance in the map, you can find the distance in the real life. Or given the distance in real life, you can find the distance in a map. Okay, so basically this is how you convert units by using the value of the scales. Okay. You have exercise 15.1. Okay, you have on the plan of the house, the living room is 3.4 and 2.6. The scale of the plan is 1 centimeter to 2 meters. So the scale is the ratio. This means that, let's copy this. This means that 1 centimeter in the map is 2 meters in real life, okay? And it says calculate the actual length. The actual length is the real length, okay? The length in the real life. So if you want to know the distance, the real distance, you have to use the scale the other way around. 2 meters represent 1 centimeters. If you measure 3.4 centimeters, what can you do? You can simplify like this to 6.8. 6.8, right? Yes. The distance is 6.8 meters. Okay, and so on, and the same with the other one. The actual distance in a map, this distance between two beaches is 12 kilometers. Okay, so you have a village over here, A, and a village over here that is 12 kilometers. And it says calculate the actual distance. It's calculate the distance on a map. Okay, so you want to find the distance on a map. So you know that the scale for number A is 1 centimeters to 4 kilometers. So if you want to find the distance in the map, the distance is measured in centimeters. So it's 1 centimeter to 4 kilometers multiply 12 kilometers. So in this map, the actual distance will be 3 centimeters. Okay? Again, if you change the scale, like this, if you change the scale, the distance in the map will be differently. Okay? Number 3, the car ramp is 28 meters long and makes an angle of 50 degrees. So you have distance like this, that is 28 meters with an angle of 50 degrees, 15 degrees. And it says how long will the ramp be on the drawing? Again, you have to find the distance on the map. What the angle will ramp make with the horizontal on the drawing? The angles are always the same. When doing maps and angles in the maps and angles in real life, they are the same. So the angle will be the same, but you have to convert these 28 meters to centimeters. Okay. We don't see angle of elevation. Here is to do a scale diagram. You have to find the values, okay, and you draw them. Remember that you maintain the angles. For example, in this case. Okay, this one says 15.2. The diagram is a rough sketch of a field of ABCD. Okay. Using a scale of 1 centimeter to 20 meters, make the accurate scale drawing of the field. Now you have to actually take out, use sheet of paper from your folder, and you have to do a representation of this geometry figure, but with these values. Okay, so let's say in your folder with a ruler and a protractor, what you have to do is this line you have to measure 120 meters to centimeters. Here we have to maintain the angle 75 degrees. Let's convert it. Let's say the distance in the map is 1 centimeter to 20 meters. Multiply the distance in the map in the real line 120 meters. You will simplify the units meters, and the distance in the map will be 6 centimeters. Okay, so with a ruler you will measure 6 centimeters. Also, again, you will measure the distance 90 divided 20, that is 4.5 centimeters. Here we have an angle of 80 degrees using a protractor, and you will measure a distance of 100 divided 20. This is 5 centimeters, and you connect all these 2 points. Okay, these 2 vertices, you connect these 2 vertices. The idea is that the scale should be something like the one here in the folder. And once you have done the squares, if you have done it correctly, but using a protractor, you can measure this angle, this angle, and with a ruler, you can measure this length, and you can convert this length into a real length. Okay? Because it says find the values of the angles. This is A, D, C, B. Find the angle BCD. You have to find this angle. And ADC, find this angle. again, if you do the drawing in your folder with the distance and the correct angles, whenever you measure the distances and the values in the drawing in your folder, those values you can, if it is a distance, you can convert it into a real distance, okay, the actual length, and the angles will be the same, okay. So draw an accurate scale drawing, find the angles, and find the length of CD of the field, okay, the actual length. What else can we see here in the book? Okay, do number exercise 2 and 3. And that's it for now. I will send you later a video for bearings for you to work after the break.